Hello, hi, good morning, my dear students. So, in the last week, we have continued the internal discussion about the thermodynamics. That is, we have begun the state functions and path functions. So, here, and finally, by the together state and path function, we derived some of the equation. That is, U. U is nothing but what? Internal energy, that is called as U. W is equal to work done. W is equal to work done. Q is nothing but heat. Q is nothing but heat. I hope you remember this further concept. H is nothing but heat, but we are going to call that as a enthalpy. Why? Because Q is nothing but, I said it is a heat. H is nothing but what? Enthalpy. So G is nothing but Gibbs energy. Free energy is. What is this Gibbs energy? G is nothing but Gibbs energy. Gibbs free energy. You will come to know about this one. And S is nothing but entropy. S is nothing but entropy. Entropy is nothing but what? I am going to tell you in detail, but the words should not be hear you as a stranger. That's why I have to using the first time for you. U matlab internal energy, W matlab work done, work. Q means heat, H means enthalpy, G means Gibbs free energy, S is nothing but entropy. S is nothing but entropy. Still is there, pressure you know, volume you know, temperature you know. So you have to remember this one. Q is nothing but internal energy. So change in the internal energy that can be represented as delta U. Delta U can be written as U2 minus U1. Internal energy means difference between the energies of initial and final state. That can be derived as delta U is equal to W plus Q. Up to here we have discussed in the last class. So change in the internal energy can depends on the work how it is varied and heat how it is varied, whether work done on the system or by the system, if it is absorbed by the system or it is released by the system. You have to remember this one. So Kannada student, you may feel something it is fast or not understand. Feel free. ಕನ್ನಡ ಮೀಡಿಯಂ ಹುಡುಗರು ಯಾರೇ ಇದ್ದರೂ ಫೋನ್ ಮಾಡ್ರಿ ಅಥವಾ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗಿಲ್ಲ ಅಂತ ಹೇಳ್ರಿ. ಯಾಕಂದರೆ ಇದು ಭಾಳ ಸಿಂಪಲ್ ಅದ ಇದು. ಆದರೆ ಆ ವರ್ಡ್ಸ್ನ ಹೇಳುವಂಥ ಇಂಗ್ಲೀಷ್ ವರ್ಡ್ಸ್ ನಿಮಗೆ ಯಾವಾಗ ಕನ್ಫ್ಯೂಷನ್ ಆಗ್ತಾವೆ ಅಂದರೆ ಇಫ್ ಯು ಆರ್ ಫೀಲಿಂಗ್ English is a little bit tough. Obviously it will happen. I am also from Kannada medium student. So Kannada medium ಅವರಿಗೆ ಇಂಗ್ಲೀಷ್ ಅಷ್ಟು ಫ್ಲೂಯೆನ್ಸಿ ಬರಲ್ಲ ಅಥವಾ ಹೇಳೋದು ಸಡನ್ ಆಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗಲ್ಲ. ನಾವು ಪ್ಯೂರ್ಲಿ ಕನ್ನಡದಾಗ ಹೇಳಿದ್ರೆ ಯು ವಿಲ್ ಫೀಲ್ ಇಟ್ ವೆರಿ ಸಿ ಅಯ್ಯೋ ಇಷ್ಟ ಐತೆ ಅಂತ ಅನ್ಸುತ್ತೆ. But I can't able to express those Kannada words. Why? Because you have to do practice that in English only. Why? Means you are going to understand in Kannada, you have to understand and you have to write that and you have to represent that everything in the English only. That's why try to understand. If not means I will be there to help you. ನಾನು ಹೆಲ್ಪ್ ಮಾಡ್ತೇನೆ ಹೇಗಾದರೂ. ಆದರೆ ನೀವು ಬಾಯ್ಬಿಟ್ಟು ಮಾತಾಡಿದ್ರೆ ಅಷ್ಟೇ ಇಟ್ಸ್ ಪಾಸಿಬಲ್. ನೀವೇನು ಹೇಳೋದು ಸುಮ್ಮನೆ ಕೂತ್ರೆ ಅಂದರೆ ನಾನೇನು ಮಾಡೋಕ್ಕೆ ಬರಲ್ಲ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಐ ಆಮ್ ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಹಿಯರ್ to help you to improve yourself, isn't it? So please do open your mouth, Kannada student, and even English students also. If you are feels confusion or trouble means I will help you. Okay. Look here, the change in the internal energy is nothing but what? It is the sum of change in work done and change in the heat in the system. Together it is called as internal energy. So here, based on this statement, we are going to derive. Give the one law, that is first law of thermodynamics. It is called as first law of thermodynamics. First law of thermodynamics. So they will give you the questions. State the first law of thermodynamics. It's important for 1 marks. Sometimes they may ask you 2 marks, but probably it is 1 mark question. Most important. State the first law of thermodynamics. So first law of thermodynamics is going to state that. Here, same as we observed in the first chapter, means there are 5 laws in gases. Those laws are actually deleted, but related to that only. Here, the first law of thermodynamics is going to say that in an isolated system, whenever I use the word isolated, you have to remember that it is heat is not changing and even matter is also not undergo the changes between system and surrounding. That's called as isolated. In an isolated system, the energy will remain constant because energy is not transferring. The system, how much energy it is containing, that will be remains here only. Because how can it changes? It is not changed by the work, not by the transformation of heat. For that reason, the heat energy or everything system energy will remain same. Here one condition. Actually, the first law of thermodynamics, it states that the energy can neither be created nor destroyed. The energy can neither be created nor destroyed. So it means that we can't able to create the energy nor destroy. So energy can only transfer from one system to the another system, from one state to the another state. Here, first law of thermodynamics is going to define us. The first law of thermodynamics states as the energy of the system can neither be created nor destroyed, but it can be transferred from one state to the another state. So ಇಲ್ಲಿ ಎನರ್ಜಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ನಾವು ಕ್ರಿಯೇಟ್ ಮಾಡೋಕತ್ತಿಲ್ಲ. ಹೀಟ್ ನಾವು ಕೊಟ್ಟೇವಿ ಅಂದ ತಕ್ಷಣ ಹೀಟ್ ಆಯಿತು ಅಂತಲ್ಲ. ಹೀಟ್ ಆಗೋದು ಅಂತಂದ್ರೆ ಸಪ್ಲೈ ಮಾಡಿದಾಗ ಅಷ್ಟೇ. ಸೊ ಸಿಮಿಲರ್ಲಿ ಹೀಟ್ ಹೊರಗಡೆ ಬಂದೈತಿ ಅಂತಂದ್ರೆ ಎನರ್ಜಿ ಡಿಸ್ಟ್ರಾಯ್ ಆಯಿತು ಅಂತಲ್ಲ. ಸೊ ಇಟ್ ಮೀನ್ಸ್ ದಟ್ ಎನರ್ಜಿನ ಒನ್ ಸ್ಟೇಟಿಂದ ಇನ್ನೊಂದು ಸ್ಟೇಟಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೋದು ಹೊರತು ನಾವು ಅದನ್ನು ನಾವೇ ಕ್ರಿಯೇಟ್ ಮಾಡೋಕ್ಕೋ ಅಥವಾ ನಾವೇ ಡಿಸ್ಟ್ರಾಯ್ ಮಾಡೋಕ್ಕೆ ಬರುವುದಿಲ್ಲ. ಸೊ ಇಟ್ ಮೀನ್ಸ್ ದಟ್ ಫಸ್ಟ್ laws of thermodynamics states that the energy can neither be created nor destroyed. ನೈದರ್ ಬಿ ಐದರ್ ಬಿ ಅಲ್ಲ, ಮತ್ತೆ ನೈದರ್ ಬಿ ಅಂತಾನೆ ಹಚ್ಚಬೇಕು. ನೈದರ್ ಮೀನ್ಸ್ ಕ್ರಿಯೇಷನ್ ಅಂಡ್ ಡಿಸ್ಟ್ರಾಯ್ ಬೋತ್ ವಿಲ್ ನಾಟ್ ಹ್ಯಾಪನ್ಸ್ in the form of energy. That is called as first law of thermodynamics. But the energy can be transferred from one state to the another state. ಒಂದು ಕಡೆಯಿಂದ ಇನ್ನೊಂದು ಕಡೆ ಅಷ್ಟೇ ಶಿಫ್ಟಿಂಗ್ ಮಾಡ್ಬೋದು ನಾವು ಎನರ್ಜಿ ಹೊರತು ಆ ಎನರ್ಜಿನ ನಾವೇ ತಯಾರಿಸೋಕ್ಕಾಗಲಿ ಅಥವಾ ನಾವೇ ಅದನ್ನು ಹಾಳು ಮಾಡೋಕ್ಕಾಗಲಿ ಬರುವುದಿಲ್ಲ. ಇದನ್ನು ನಾವೇನಂತ ಕರಿತೀವಿ, ಫಸ್ಟ್ ಲಾ ಆಫ್ ಥರ್ಮೋಡೈನಮಿಕ್ ಅಂತ ಕರಿತೀವಿ. ಇಟ್ ಇಸ್ ಇಂಪಾರ್ಟೆಂಟ್. ಫಸ್ಟ್ ಲಾ ಆಫ್ ಥರ್ಮೋಡೈನಮಿಕ್ ಅನ್ನು ಇಟ್ಟುಕೊಂಡು ಕೆಲವೊಂದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ಲಿ ಹೇಳುವಂಥ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇದ್ದಾವೆ. ಬಟ್ ಆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನು ಹೇಳೋಕ್ಕೆ ಸ್ವಲ್ಪ ಟೈಮ್ ಜಾಸ್ತಿ ಬೇಕು. ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಏನು ಮಾಡ್ತಿದ್ದೀನಿ ಅಂತಂದರೆ, ಆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಎದುರು ಬೇಸ್ ಮಾಡಿದ್ದಾವೆ ಅಂತಂದರೆ ಲಾಸ್ಟ್ ವೀಕ್ ವಿ ಹ್ಯಾವ್ ಡಿಸ್ಕಸ್ಡ್ ವಾಟ್ ಈಸ್ ದಟ್ ಪಿಸ್ಟನ್ ಥ್ರೂ ನಾನು ಹೇಳಿದ್ದೆ ಪಾತ್ ಫಂಕ್ಷನ್ಸ್ ಅಲ್ಲಿ. ಸೊ ಪಿಸ್ಟನ್ ವರ್ಕ್ ಡನ್ ಆನ್ ದ ಸಿಸ್ಟಮ್, ವರ್ಕ್ ಡನ್ ಬೈ ದ ಸಿಸ್ಟಮ್, ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ನೆನ್ಪಿಟ್ಕೊಳ್ರಿ. ಆ ಕಾನ್ಸೆಪ್ಟ್ ಬೇಸ್ ಮೇಲೆ ಐ ವಿಲ್ ಕಂಟಿನ್ಯೂ ದ ನೆಕ್ಸ್ಟ್ ಥಿಯರೀಸ್ ಆಲ್ಸೋ. ಸೊ ಹಿಯರ್ there are two kinds of the properties. So in property, one is external property, another one is internal property. External property, another one is internal property. Always it is also called as extensive and intensive properties. Yes, extensive and intensive, not external, it is extensive property, intensive property. Here these are the some properties which are differentiated or explained on the basis of mass of the system. Means here some of the properties if they are depends on the matter, means how much matter is present. If the matter is variable, then it is called as some kind of the properties. Look here. So initially we are having two types, one is extensive and one is intensive. Here extensive property is a system which whole value is depends on the size of matter present in the system. It means the extensive property is a property which depends on the mass of the system, mass of the system is nothing but, ಈಗ ಇದರ ಅರ್ಥ ಏನಂತಂದ್ರೆ ಎಕ್ಸ್ಟೆನ್ಸಿವ್ ಪ್ರಾಪರ್ಟಿ ಅಂದರೆ ಯಾವುದೇ ಒಂದು ಪ್ರಾಪರ್ಟಿನ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ್ಕೆ ಹೋದಾಗ, ಅಬ್ಸರ್ವ್ ಮಾಡಕ್ಕೆ ಹೋದಾಗ ಮಾಸ್ ಏನಾದರೂ ಚೇಂಜಸ್ ಆಗ್ತದೆ. ಇಫ್ ದ ಮಾಸ್ ಇಸ್ ವೇರಿಯಬಲ್, ಮಾಸ್ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂದರೆ ಮಾಸ್ ಇಂದನೇ ಇದು ಡಿಪೆಂಡ್ ಐತಿ ಅಂತಂದ್ರೆ ಸಚ್ ಕೈಂಡ್ ಆಫ್ ಪ್ರಾಪರ್ಟಿ ವಿ ಕ್ಯಾನ್ ಕಾಲ್ ದಟ್ ಆಸ್ ಎಕ್ಸ್ಟೆನ್ಸಿವ್ ಪ್ರಾಪರ್ಟಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, if I wish to calculate the mass is in the form of kg. mass, ಈಗ ನಾವು ಮಾಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ಮಾಸ್ ಜಾಸ್ತಿ ಇದ್ರೆ mass will be the greater. If quantity is matter is less, means the mass will be the less. It means to calculate the mass, the matter is considered. Greater the matter, greater will be the mass. Lesser the matter, lesser will be the mass. Means mass is depends. If mass is depends on the property, then it is called as extensive property. The property which is depends on the mass is called as extensive property. The property which is not depend on the mass is called as intensive property. mass is first property which is depends on the mass. Another one is volume. Think that the volume of the container here, this one, here, this one. ಈಗ ಗ್ಯಾಸಸ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅಥವಾ ಸಾಲಿಡ್ ಅದ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಸಾಲಿಡ್ ಸ್ವಲ್ಪ ಇತ್ತಂತಂದ್ರೆ ವಾಲ್ಯೂಮ್ ಸ್ವಲ್ಪ ಇರುತ್ತೆ. ಇಫ್ ಐ ಆಮ್ ಪರ್ಸನ್ ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಹಿಯರ್, ವಾಟ್ ಇಸ್ ದ ಮೈ ವಾಲ್ಯೂಮ್ ಮೀನ್ಸ್? ಮೈ ವಾಲ್ಯೂಮ್ ಇಸ್ ಲೈಕ್ಲಿ ಒನ್ ವೇ, ಎಷ್ಟು 1 ಲೀಟರ್ ಅಥವಾ 1 dm³ ಇದೆ ಅಂತ ಹಂಗೆ ಅನ್ಕೊಳ್ಳಿ, ಸೈಜ್ ಪ್ರಕಾರ ಹೇಳ್ತಾರೆ. Otherwise we will take the best example here. These are the two choppies I am having. Can you see here? This is also choppies, this is also choppies. Which one is having the greater volume? This is also choppies. It is having a smaller. Why? Because size is small. It is having larger. Why? Because size is larger one. What about the mass? Does it have larger or both are having the same mass? No. This is the choppies is having larger in the size. It is having greater mass compared to this one. Here we are going to discuss about the volume. This volume is depends on the mass. Depends on the mass. For that reason, no doubt this choppies is having the greater volume, but it is also having the greater mass. This choppies is having the lesser volume. No doubt it is also having the lesser mass. So it means that volume of the system is depends on the mass of the system. Therefore, volume is also considered as an extensive property. Extensive property is nothing but the property which depends on the mass, then it is called as extensive property. Next one is internal energy. Internal energy is nothing but U. Next is enthalpy. Enthalpy is nothing but H. H is called as enthalpy. And heat capacity. Next one is heat capacity. Actually heat capacity is represented as Cp, capital C, small p. It is Cp, heat capacity. How much the heat can be stored in the matter? Stored in the matter means think that a small metal we are having, another one is large metal. If I heated the metal, that metal can store the heat for some extent, but the large metal can have the storage of heat by larger extent. Means heat capacity will be greater for the greater mass and lesser for the lesser mass. Even the enthalpy and internal energy, these are going to vary based on the mass. These properties are depends on the mass. Therefore, these are called as extensive property. Define extensive property. Give example. The property which depends on the mass of the system, are called as extensive property. Example: mass, volume, internal energy, enthalpy, heat capacity. These are called as extensive property. Similarly, what is intensive property? Give example. Here, the property which do not depend on the mass of the system. If it is not a variable on the basis of mass, then it is called as intensive property. Define intensive property. Give example. Here, intensive property example is melting point, boiling point, density. These are the nature observed by the properties. These properties are not depends on the mass. Pressure and temperature. So these are not necessary to look at the mass. How if the mass are not going to change? If I want to calculate the boiling point of this one, means I can calculate the boiling point of this chalk if it is smaller or it may be a larger one. Means whether it is soluble or not, this chalk is to check this one means no need to take the larger one only. If the smaller is dissolved, if it is dissolved means no doubt larger will also going to be dissolved in the water. So in this condition, mass is doesn't required. The mass is not mandatory here. For that reason, it not depends on the mass. The intensive property is a property which do not depends on the mass of the system. Such kind of property is called as intensive property. The example is melting point, boiling point, density, pressure, temperature. These are called as intensive property. Here these two terms are more important here. You have to remember Sometime they will ask you the difference, write the difference between intrinsic property and extrinsic property. If they ask you the difference, you have to make two separate columns, intrinsic property and extrinsic property. First you have to write the definition. Definition itself is the difference for the intrinsic and extrinsic. Next one you have to say that the extrinsic depends on the mass, intensive more depends on the mass, and then finally you have to write the example for the properties. So probably they will not ask you the difference. If they ask you something, means surely you have to make the two columns. One is for intensive and the other one is for extensive. For all the differences, must and should you have to make the two column, and you have to write the differences. And one point if you have written here, the opposite to the same point you have to write. If you are talking about the volume, you have to talk about the volume only. If you are talking about the density, then you have to talk about the density here. Here you have written volume, means you are not supposed to write the density here. What factor you are writing, the same factor will be continuing in the same line in the opposite to that one. So this is what you have to remember here. So main thing I would like to recall you here: intensive property and extensive property, and first law of thermodynamics. These are most important in the today's class. Whichever I have explained, everything is important here. So for the next class onwards, we will know the applications of thermodynamics. So here in application we are going to discuss about the work and heat, how the work is changing, how the heat is changing. If the work done by the system, what happens? If the work done on the system, what happens? We will check it out once again by observing the same system. So I said in the last class, whenever I said the system, you have to look that here system is nothing but what? A container containing the sum of the materials along with the piston. So these are called as system containing some material along with the piston. If I pressured the piston, means it means work done on the system. If it expands, it means work done by the system. You have to remember here. Compression is nothing but what? If I am applying the pressure, this is called as, after applying this one, what happens? Compression is appears. Compression. If compression is happened, means work done on the system. Work done on the system. When means when the gaseous compounds are compressed. Can you see here? Here the particles are far away. The particles are far away. If I apply the pressure, if the piston moves down, then what happens here? The gaseous particles will be near to each other. Can you see here? Here the gaseous molecules are far away. When I apply the pressure, that is called as compression. If the gases undergo the compression, then work done on the system it is. Means I am doing the work on the system. If the gases are here compressing, that is work done on the system. Here after some time what happens? The gaseous compounds are going to expand. If they expand, means that is called as releasing. So expansion is nothing but what? Work done by the system. By the system it is called as expansion. Compression is nothing but work done on the system. Expansion is called as work done by the system. You have to remember, in the last classes we were not having the observation. Compression is nothing but work done on the system. It is on the system means you have to write the plus W, means work done is positive. If expansion is happened, means work done by the system. At that condition, work done is negative. So these are the main important terms here. We will continue that application in the next classes. Until, do remember these all things. We will meet you in the next class. Until, if you are having any doubt, ask me. Have a nice day.